Determine the equation of a parabola with focus at -1, -2 and the equation of the directrix as given to us. Let us begin. We'll try to understand the problem graphically. We'll start by considering a vertical line. So this is for understanding purpose. I'm considering here a vertical line. So here, let's say this the equation of this line will be x minus 3y plus 3 equals to 0. Now what we'll do, we'll draw a line which is perpendicular to this directrix line. That's also will be referred to as the axis of symmetry line. Now on the axis of symmetry line, we're going to consider a point, let's say point F. This point will be referred to as the focus. So that's -1, -2. Our goal will be to use these two information to find out the equation of the parabola. To begin with, what we'll do, we'll consider a point P. So this is a point P. Let's say its coordinates are h, k. Now this is a moving point, so also referred to as the locus. So this is the locus of the parabola. Using the point P, we'll try to find out the equation of the parabola. First, we'll begin by joining point P and point F, and we'll also drop a perpendicular from this point P on the directrix line. Let's say it meets the directrix line at point M. Now by definition, we know, because for a parabola, this distance, the point P is placed in such a way such that the distance PF will be always equals to the distance PM. Now, we can easily find out the distance PF as well as the length PM, because to find out the length PF, all we have to do is use the distance formula. So here we will take the square root. Underneath the square root, we need the difference of the x coordinate. So here, x coordinate, difference of the x coordinate will be h minus -1. So we get h plus 1. We need to square this value and then add it to the difference of the y coordinates. The y coordinates will be k plus 2 whole square. So we have obtained the length of PF. Now to find out the length of PM, this is going to be the perpendicular distance of the point P from the straight line or the directrix line. So there's a standard formula for obtaining the distance PM as well, the perpendicular distance PM. We'll take the absolute value. Underneath the absolute value, we'll take the ratio. In the numerator, we'll take the coefficient of x of the directrix line. So that's 1. 1 will get multiplied to the x coordinate of point P. So we have h multiplied to 1. That simply gives us h. Then we'll take the coefficient of y of the directrix line. So that's -2. -2 gets multiplied to the y coordinate of point P. So we get -2 times k. And then we have the constant term, that's plus 3. This will be divided by the square root of the sum of the squares. Sum of the squares, that means we'll have to take the coefficient of x, that's 1, square this value, and add it to the square of the coefficient of y. So that's -2 squared. Okay, now we will simplify this. So this is going to give us the square root of, so expanding h plus 1 whole squared gives us h squared plus 2 times h plus 1. Added to k squared plus 4k plus 4. That will be equals to the absolute value of h minus 2k plus 3 whole divided by the square root of 5. Now what we'll do, we'll get rid of the square root on the left hand side and the absolute value on the right hand side by squaring both sides. So here we will get h squared plus k squared plus 2 times h plus 4 times k plus, so this 1 and 4 will get added to give us 5. That will be equals to, on the right hand side we have h minus 2k plus 3 whole squared divided by squaring square root of 5 gives us simply 5. So we're going to cross multiply this 5 with the expression on the left hand side, and that's going to give us 5 times h squared plus 5 times k squared plus 10h plus 20k plus 25. This will be equals to, now we need to expand h minus 2k plus 3 whole squared. So that's h squared plus 4k squared plus 9 minus 4 times hk minus 12k. Then plus we have 6h. Now we're going to combine the like terms. So 5h squared minus h squared, that will be 4h squared. Then we have 5k squared minus 4k squared, that will be simply k squared. Then we have 10h. This will be, from here we'll be subtracting 6h to get positive 4h. Then we have 20k, now negative 12k, that transpose to the left side becomes positive, so we get 32k. Then we have positive 4 times hk, and then we have 25 minus 9, that's going to be positive 16 equals to 0. And to find out the equation of the parabola, we have to replace the value of h with x and the value of k with y. So that was going to give us 4x squared plus y squared plus 4 times x plus 32 times y plus 4 times xy plus 16 equals to 0. So this is the equation of the parabola. So this is the required equation of the parabola, whose equation of the directrix is x minus 2y plus 3 equals to 0, and the focus of the directrix will be focus of the parabola will be at -1, -2. What we can do, we can use a standard graphing calculator to graph the parabola. So let's have a look at it. So this is going to be the graph of the parabola. So here we have the focus. Let's try to plot -1, -2. So -1, -2 is going to be at this particular point. So this is going to be the location of the focus of the parabola, and the blue line is going to be the directrix of the parabola.